All right. I really feels like our progress is getting better and better, right? Okay, and we will go on to chapter 7, which is the last chapter in this semester. Okay, that's my plan. Okay, if I can finish all the materials and you'll get into that step, then I like to turn in the last assignments on 29th. That means 2 weeks from today. But if I cannot finish within these 2 weeks, then that will be the January the 5th. I'm not sure yet. Okay, and that will be our last assignments. And the final exam week is on the January 12th, and we don't have that class that day. So the last day is the January the 5th. Okay, including all the presentations. Okay? Huh? Huh? Excuse me? So fast. I mean, the semester is so fast. Yeah, it flies. But I don't know. I really think that the class progress is getting much, much better than the beginning. Okay, for the first 3 chapters, 4 chapters, we're really in not that good situation. But so far, after chapter 5 and up to chapter 6, I think it's getting better and better. Okay, you all feel that? Do you feel that you have more ability to hang on dealing with this class? You all feel that? Okay, that's good. Very good. Okay, that means we build a pretty good foundations for this regression analysis. And I believe that most of you will do something like this research, for your thesis. Quantitative analysis, okay, especially for the regressions. Okay, all right, so I really hope that this class help you a lot. Okay, even you don't have knowledge about statistics before undergraduates. Okay, I think you will, really get good benefit of taking this course. Okay, so today I'm going to talk about the chapter 7. Let's turn to the page 207 from our textbook. Okay, this is another topic about the simplification. Okay, when we talk about using the words simplification, usually in regression is the model. Okay, how to decide independent variables, and this is we talk about in chapter 6, choosing the correct independent variables. So we have several criteria, right? Theory, we're using adjusted R-square. We have this hypothesis testing, and we look at the bias. And the bias really is checking, maybe using the partial F test and t-test. Okay, and we also add up some criteria, which is AIC, BIC, and Hannon-Quinn criteria. Okay, those, in the future, if you are working your thesis, you can all use this kind of criteria. It's a good criteria. It's the popular criteria which is useful for your model simplification. Okay, and in chapter 7, we're talking about the functional form. Okay, choosing a functional form. Does anybody want to tell me that what do we mean by functional form? Evan?
The equation where we have independent variable, the coefficients for every variable, for every independent variable. No?
Well, yes. When we say the correct model, not only the variable is independent variable itself, but also the functional form of an independent variable. So in other words, the topic difference between chapter 6 and chapter 7. Chapter 6 telling us that choosing the correct independent variable. And chapter 7 talking about those correct functional form of the independent variable to the y variable. Okay? So when we talk about functional form, it really doesn't mean we didn't talk about the omission of the variable. Okay? We already choose the appropriate x variables, but we still have to thinking about the relationship of the x variables, which is the functional form. Okay? And usually we look at the regular equations, regression functions, usually we're just saying that x1, x2, x3, x4. Okay? But the functional form in mathematics, when we say functional form, is the relationship of x to y. And it cannot be just linear. And remember that we talk about the linear, the meaning of the linear. Do you all remember that? What do we mean by linear? When we talk about chapter 4, okay, we talk about the regression model. We call this is simple linear regression or multiple linear regression. What do we mean by linear here? Oh, remember that?
Yeah, I remember.
Okay.
The coefficient is like just normal number. There is no powers or logarithm or stuff. It's just like the normal value. I would say like a simple number. Negative, positive, but still.
Okay, I would say that the power, you all know the power? Okay, the power of the coefficient is equal to 1. The power of the coefficient is equal to 1. This one is the coefficient, right? If this means the coefficient, the power is equal to 1, right? We never use the 1 here because it is unnecessary, right? So this means the power of the coefficient equal to 1. So when we say linear, it means that linear in the parameters instead of linear in the variables. Remember, there's two terms, and I like to mention it again. Linear in the parameters. Sometimes they say coefficient. Since this is coefficient, right? Okay? Or linear in the variable. So linear in the regression model is talking about linear in the parameters instead of linear in the variables. In other words, the beta is just the power of the beta is only 1. But the variable of the linear regression model cannot be 1. Okay? So in other words, this is y, beta 0, beta 1, x1, beta 2, x2, etc. Beta k, xk. This is the model, linear, not only in the parameters, but also in the variables. And this is usually what do we see from the regression models, right? So in the beginning, we are thinking that this is what we say, the linear. But actually, not only this. This is really linear in the parameters and also linear in the variables. But when we say regression model, the linear means linear in the parameters only. Therefore, if I have the model, something like this one, sorry, this is one. This one. I have x1, I also x1 square. Okay, so this means linear. This is not linear in the variables because I have x1, which is square. But is this a linear regression model we are talking about? Yes, because it is linear in the parameters. Okay? Understand what I'm saying here? Okay, so if you turn to the page of this chapter, okay, let's just see all this. Look at table 7.1 on page 219. This is the most popular functional forms we are talking about in the regression model. You see that? You see that model? Let me see. So you have the book. Did you show the model? Table 7.1 at the back of the chapter. Table 7.1. You see that? Okay, we are going to talking about this 5 popular forms in the regression analysis. Okay, and this is what we call functional form, correct functional form. Okay, so the first one is what we call it linear functional form, and this is the one we usually see. Okay, since they are just using simple linear regression, but if you extend it to the multiple regression, it works too. Okay, so let's see linear functional form. Okay, which you can see not only the parameters but also the variables. And how do we interpret the coefficient? Beta 1. We say it is a slope. Then what do we mean by slope? It really explains it at the third column. Say if x increases by 1 unit, y will change by beta 1 units, isn't it? This is how we interpret the beta 1. Okay? Then there's second functional form, okay, which is called double log. Have you heard about log function? Well, maybe those of you in the undergraduate is not in science or something, or in language, but I think all of you learn this one when you are in senior high school, right? Okay? Okay, so the second one called double log, and usually in business, since this is talking about the economic entities, so usually we are using natural log. This is what we show it is ln. This is natural log. We have two logs. One log is the base of the log is 10. The other one, the base of the log is natural numbers. So I'll put it here. When we say log, sometimes is using log 10 as a base. What do we mean by this? This means when you have the number 10, okay, take the log of this one, since it is using 10 as a base. So means log 10 raised to the first power, 1 power. And since this is by base of the 10, so this is equal to 1. Okay? If you don't understand this one, please just remember this. Okay, since this is based on 10, so if you have the number 10, it means raised to the 1 power. Then you take the log of it, the number is equal to 1. So the original number is 10, but you take the log of it, it becomes to 1. You see what I'm saying here? Then, but if you have natural log of 10, this is different. The natural log means the log using E. E is what's the number of this one? How to say this number? E. How to say that? What kind of numbers? I think there's a name on it. Natural number or something? Huh? What's the meaning of any special term? I remember there's a special term, E. Anybody knows? 自然数. In Chinese, it's 自然数. So what is it? All of a sudden, huh? Euler's number. Okay. All right, let's just say that's Euler's number. But it's E. And E is equal to something like this one, 2.17, something. I don't remember all the decimal places. So this means that log using this numbers as a base. Therefore, how do you think? If I use the 10 and I take the natural log, this is what we call natural log. Okay? Now what's the number? It's using 2.7 something and raised to the some power which is equal to the power. So how do you think this number is greater than 1 or better, lower than 1? Do you all understand what I'm saying? Let's use evils. It's easier to understand it, okay? I have 1, 10, 100, 1,000. Okay, I'm just using these two numbers, okay? Then if I take the log, I can use the function of Excel, okay? So if I use log, actually if I log, did you see that? This is log. This is log. Okay? So I'm using log. Then how come it didn't show the log here? Or maybe I need to tell them take log of what? This A2, this variables. So I put this A2 here. Then this is equal to 0. Why it is equal to 0? 1 is equal to 10 raised to the 0 power, right? So that is equal to 0. Any numbers raised to the 0 power equal to 1. This is in math. Okay? I have to teach you math. Okay, so this one, I'll do all of them. Yeah. So, this is 1, 2, 3, right? Because 10 is 10 raised to the 1 power. 100 is 10 to the 2nd power. This is the 3rd power. Okay? Then how about natural log? So that means, let me just write it. This is by log, and this is by ln. Okay? And using the same function, ln A2. They have different numbers. Okay? This means that if I use E as a power 10 equal to 2.7 something raised to what power equal to 10? This one tell me that raised to the 2.3, etc. As a power. Okay? So this is 2.3 something. So this one, using the natural log, is 2. This using natural log is 4.6. And this one will be 6.9. What's the difference between log and natural log? Look at all this number. What's the difference between these two? What is this, the relationship between these 3? This is original number, right? This is original number. And this is the log, and this is the natural log. What do you see from, what's the difference? Positive relationship, okay. Anything else? Look at this one. This is the range is from 1 to 1,000. Okay? And the range of this one is from 0 to 3. Okay? So the range is getting very small. The range of this one is 1,000. Right? I will put this one here again and show another information from here. How about 0? How about original number is 0 if I take log and natural log? What does that mean? This means undefined. So you are not able to take the log, either natural log or regular log, when the number less than equal to 0. I mean, those negative numbers including 0. We're not able to use this log and natural log with negative numbers and also 0. So they are all in positive. And in the business area, most of the numbers is in positive when we're interested in. Most of in positive. Okay, so from here you know that if your original number, the range of original number is bigger, you can use two ways to smooth the data. Okay, either you use log or natural log. So in this case, what's the difference between these two? This is from 0 to 3, right? This is from 0 to almost 7. So what does that mean? Huh? This range is wider than this one. So usually by regular log, the speed of the smoothness is more faster than the natural log. Okay, and it is believed that in economic side, okay, using the natural log is more reasonable than the regular log. Therefore, when we see all this economic data, okay, look at the functional form, we have it here, is all take natural log instead of regular log. Okay? All right. So this, when we say double log, means what? Double log means we take log of y, we also take log of x. Double log. Two sides. Either y or x takes log of it. Okay? And in this case, how do we explain the beta 1? This is very important in business world, okay, in business research, okay. If you have double log functional form, what do we mean by beta 1? How do you explain the beta 1? You know, this table is important, and especially for the third column, okay, which tell you how to interpret the coefficient with or without natural log. So if you have the double log with y and x, so here the beta 1 will be interpreted as if x increases by 1% instead of 1 measurement units. Okay, mark it down, 1%. Y will change by beta 1%. Okay, and there's a lot of economic theory talking about this one too. And we have the spatial name on this one is called, did you see the terms? Thus, beta 1 is the elasticity of y with respect to x. So please mark it down, elasticity. Okay? Usually, if they don't take log, we call them, the beta 1 is slope. But if we take the log for both sides, the beta 1 becomes to elasticity. This word, elasticity, is important in business world. Okay? And what do we mean by elasticity? Means x increases by 1 unit. Then how much the change in, how much percentage change in y variables. Okay? Then look at functional form, the third one and the fourth one. Okay, they all call it semi-log. Semi means half. Okay? So semi-log since half. So it is either by x, takes the log of x, or takes the natural log of y. Okay? So the third one is take the log of x. And the fourth one is take the log of y. Just just either one of them. So we call it semilog. And how do we interpret the beta one? Okay, look at this one. If x takes log, means that if x increase by 1%, y will change by beta 1 over 100 units. That's so different, right? So whatever those variables go with natural log, when you do the explanations, you have to say change by percent, 1%. Then the one without natural log then will be the units. Okay? So since the third one, we take the log of x. So the explanation of the beta 1 will be if x increases by 1%, since x take the natural log. So x increases by 1%, y will change by beta 1 over 100 units. Then if you take the log with y, so this is a semi-log, then how do you interpret the beta 1? Just do the opposite way, okay? Then let's see. If x increases by 1 unit, since x doesn't take the log, so we'll say increase by 1 unit, y will change by roughly 100 times beta 1%. Okay, then the last one is what we already have learned when we're in junior high school, right? Polynomial. So this one, polynomial is with x variable has the second power. And this is called a polynomial functional form. And actually, if I have the x variable with the second power, then what's the diagram it looks like? This is what we learn in the junior high school and senior high school, right? That will be parabola. We call it parabola. 抛物线 in Chinese. Okay, parabola. We have U shape or this U shape. It's the open mouth upward or open mouth downward. Okay, you may see all the diagram. Let's see from our books. Let's see all this diagram. Okay, it shows the diagrams. Look at on page 213. Figure 7.2. This is double log functions. They're using x1 and x2 variables as an example. Okay? And since this is, look at the left one is, how did you call this one? This is双曲线 in Chinese. I don't know how to anyway. Okay, but the shape of this double log, it really depends on if we see the y and x1. Okay, we are not able to see both of x variables in the two-dimension diagram, right? So look at one by one. So if you wanted to see y and x1, it really depends on what beta is greater than 1, greater than smaller than 0, and between 0 and 1. The shape is really different. Something like this one and this one and this one. Okay, really different based on the beta. It's negative or positive or between 0 and 1. Okay, so if you don't have any ideas about those functional forms, just see the diagrams from our textbook. It gives you very, very good ideas about it. Okay? Then look at the figure 7.3. Okay, on page 216. Okay, this is a semi-log function, and if we also look at y and x1, since it takes these examples, the left-hand side is showing take y as a variable, as a semi-log, okay, and the right-hand side is using x as a semi-log. The diagram is different, okay. You understand what I'm saying here? This is all math. But, we just have this general idea. That will be fine. Okay? This is a good place to start with, to know all this relationship with y and x. Okay? You don't have to really, memorize this one or really, really understand of that. Just take a look at it, just like any kind of pictures. Okay? Then you have the feeling about it. Okay? Well, the polynomial forms, look at the figure 7.4. So one is also in terms of the square of x1. Okay? Then since the square with the first power, also the second power, and this is what we call parabola. Then parabola, there's two kinds of parabola. One is the mouth is open up. The other one is mouth open down. Okay? So in economics, okay, there's a famous theory about economics. From the left-hand side means the mouth open up means we have the bottom line of these parabolas. And the right-hand side is mouth open downward. There's a maximum of the y, or maximum of the x variables, the amount of x. Then on the class I will give you some examples to have more feeling about it. Okay, so this is all the popular functional forms which we will learn in this chapter. Any questions about this one? So chapter 7 is talking about the functional form. In other words, we need to have the correct x variable at the beginning. Then we talk about the correct functional form from this relationship of x variables to the y variables. Okay? All right? Any questions about it? So today we are talking about the linear regression model in the linear regression model in the regression analysis is really saying the linear in the parameters. And since it is linear in the parameters, and we end up with this 5 populars, in the math, there's kind of all kinds of different forms, functional forms. But in business world, okay, or in big economic theory, because all business was related to the economic theory. Okay, based on this economic theory, these 4 functional forms is popularly used in business research. Okay, so you need to understand more about this functional form. Any questions about that? Okay, if you don't have any questions, then maybe we'll. Okay, I when I see your assignments, Okay, and I like mention one thing, which is maybe very smaller, but if you pay attention to this one, it makes all the report looks beautiful. Okay, when we do the bias, okay, we need to have, when we calculate the bias, we need to have some estimated notations, which we put a hat on it. Okay, how did you put a hat on it to make it prettier? I saw some of them is prettier, but some of them is not prettier. It's not pretty. We're not only ask for the correctness, we are also ask for the pretty of the printing, right? Okay, let me say something about this one, okay? It's all about the functional of equation, okay? So let me show you how to do it, okay? If you want to do the beta 1 hat, how would you do it? Now, I'll go to the equation function, okay? Then I'll choose this one first, which tell me that I can use the beta 1. I have the subscript, right? Or if I want to have square, that's subscript, okay? So do this one first. Then, if this is 1, then do the beta, okay? If you want to do the beta, you can do this one. I think you all know how to do it, right? Let me choose, this is the beta. Then, put this one here, okay? Then choose the function like this, and choose the head on it. Did you see that? If you choose this one, the head is such beautiful on the top of the beta instead of including this one. If you highlight all of them, let me do it again. I'll do another one, which is not pretty. I saw you. My eyes can see anything. Okay. Well, it's very. I really since this is my professional skill, so I can see what if you highlight this everything, then look at this one. This is not pretty. This one is pretty. Do you think so? So I hope all your thesis, using this one instead of this one. Okay? Just highlight this one and put a head on it. Yes. Yeah, huh? R square? A head of R square? Okay. I'll do it again. This one and what's wrong with here? I don't know what's wrong with here. Okay, let me go to another lines. Okay, equation. R square? Yeah, I'll put this R square first. Then I'll put 2. Okay, then put the R and highlight the R. Then put this one. Isn't that pretty? Look at this one. Instead of, I'll show one thing which I see what you have done. Okay. This is really small, but makes your advisor happier. Isn't that important? 2 R, then put this one. Look at this one. This is the difference, okay? I don't want to put the head on the square on it. I just want to this one. So this is much better than this. Yes? Bar is also, bar is something. Okay, look at this X bar. Okay, X bar or X1 bar. Okay? X1. So X1 bar, right? So 1, then X. Okay, then highlight the X, then put this one, and there's a bar on it. That's it. So I like just this instead of everything. Oh, I mean, there's a head on it. Then, huh? No, it's R square bar. You mean, okay. R square R. Oh, okay, just the R square. Okay, let me do this one. Do this one again, okay? The equation, R square. Square. Then R, right? You want to put the R bar, right? Put it on here. This is pretty. Huh?
Which one is the correct one?
Huh? Excuse me?
Which one is the correct one? Should be the head or the bar for adjusted?
Well, in our textbook, the notation is using R bar. Yeah, this is notation from our textbook. There's no really standard. Some books doesn't use any notation. They're just using adjusted R square. They put adjusted R square. Or maybe they was put 8 here. This one.
What does it mean exactly? I still didn't understand.
Hat is the estimate.
It means there is no hat. What does that mean?
If there's no hats, means the parameters. If there's a hat on it, it's statistics. That's from sample.
Okay.
Oh, that's big difference. There's big difference in statistics. Okay, I'm saying this one. Maybe some of were using this one.
But the coefficient we're using are always estimated coefficient from the regression analysis, right?
So it should be put hat on it.
Yes. When should we not put it the hat?
The population model.
So when we do the
Okay, like we do in our correct model is the population model. The estimated model is the one, when we calculate those bias, we have to put the hat on it because all these coefficients, the bias is coming from estimate of the sample. Therefore, you should put hat on it. Okay? That's the big difference. Okay, I'm saying that this one, okay, if you have both sides, okay. What I'm doing now. So I'll doing one with this one, okay? R square and adjusted R square. So some of the notation we're using adjusted R square, something like this one. And this one looks pretty, right? So always go through the perfect one. Okay, that's for today. Although this is not really econometrics, but this is for your thesis or all the reports. Okay, you submit it to your professors. And as long as it is prettier, then the professor looks happier. All right. That's for today. Thank you very much.